Good morning or good afternoon for everyone who's on the East Coast or in Europe. I'm going to share my screen and make sure that is good and then carry on. Yeah, go, shoo. Okay, this look good on everyone else's end here.
Yep, looks good for me, Carl.
Right. So yeah, like Danielle said, I'm Kyle Payne, and then I'm here with David Tinkle. David's actually in our UK office. We're going to talk through a real live example of transitioning an HFC store off of HFCs onto transcritical CO2. And we're going to talk about it kind of start to finish. So from the system design, the actual implementation design, the actual execution of the project, and then how we actually help commission and monitor that system remotely, and then take it over from there remotely as well through our Low Connect service. So just a little bit, I'm Kyle Payne, our head of US retail. So I specifically work with really three of our different brands, which we'll talk about here in a minute in terms of how they come to the US market. Then Dave, if you want to give a little intro on yourself.
Yeah, thanks, Carl. Yeah, David Tingles, Operations Director for Low Connects. Been working for Low Connects now 15 years and kind of specialize in that onboarding, connecting, and then managing, the connected estates, especially in kind of the CO2 transition sector.
So for Low, there's really three different brands that sit under our umbrella that works with grocery retail. The most like well-known one in the US is Low Rental, but within that umbrella of retail-oriented services, we have a specialist refrigeration design consultancy called Abbey Design. So Abbey Design has been working with retailers in the UK primarily on CO2 transitions since 2010. And really the retrofit part of that since like 2011, 2012. So you're talking about 12 years or so of direct experience retrofitting transcritical CO2 systems into HFC stores. So we really pull from a lot of that experience here in the US on the rental side of our business, which over the last couple of years has really been geared towards helping stores here pull off these large remodel projects to CO2 in a disruption-free way. And then Low Connects is a universal remote monitoring platform that was originally designed for CO2 systems. It's really grown from there to ingest data from all sorts of different assets outside of refrigeration. But it's particularly useful, and we'll talk about it in this case study here, where you're actually commissioning the new CO2 system remotely and helping that process out. So I'm going to talk through the first two layers of this, the Abbey Design and the Low Rental part, and then Dave will start taking over with the Low Connects part. And this actually worked out really well, because if anyone was at the webinar last week, Ed gave a really nice presentation on some of the available options that are out there for transitioning to natural refrigerants and how they can be implemented in stores of various sizes. We obviously help with all of those, but today we're going to be very much laser focused on taking HFC to transcritical CO2. So we're going to talk about one store example. We're going to talk about how all three of those different services played a role in helping this be executed successfully. So this store, just under 65,000 square feet, they were converting three existing HFC racks over to two transcritical CO2 racks. So we did the entire system design for this with Abbey Design. We did the project phasing and sequencing. We provided the rental temporary refrigerated cases that helped with the changeover from HFC to CO2. And then as that was going on, Low Connects was deployed not just on a temporary basis, but this was their monitoring service from start to finish, to help remotely commission the system and then monitor it and optimize it once it was in operation. So this is the system, or the refrigeration equipment layout, color coded by system. So what we're going to do here is walk through this in a play-by-play sort of way. So some housekeeping items as we walk through this. The schematic is color coded, so there's always going to be a description in the top left showing what we're removing in that phase, what is going in that phase, and if anything is moving around. And when it comes to converting HFC to transcritical CO2, the number one thing we're really looking for when we're doing this is how can we put a stable load on the rack without disrupting store-to-store trading. So a lot of this involves shifting around and moving around of some existing fixtures to create room to put that first stable load on the rack. So this, depending on the size of the system you're putting in, can be anywhere from 10 cases to 15, 20, or even 30 cases, depending on the size of the rack. And we're always looking to put that first load on the system with the original load it was designed for. So we stay away from false loads and things like that. Then this is really why the temporary cases are so important, is it allows us to take a lot of cases offline at one time to give the contractor the space and the time they need to actually install and then properly commission that first CO2 rack. So what we do in the first part of this process here, and I'm going to see if I can use the little laser pointer here. Dave, is the laser pointer working for you?
Yeah, that's on.
Okay, excellent. So what we're doing here to start, and you'll see we're going to focus on this right side of the store first. If we can help it, we always try to do medium temp lineups first when putting the first load on a transcritical CO2 system. So what we start off doing is clearing out some space here. Merchandise from these fixtures goes into the temporary cases that were brought in. Next phase, not much happens here. There's just some cases moving around. The store was getting a new perimeter department, so some stuff had to get bumped off the wall. Nothing crazy happening here, at least as far as the transcritical CO2 part of this goes. So right here, this is kind of the step before we actually put rack one into place. So what's going to happen is you see a lot more self-contained cases were brought in from a temporary standpoint. These are merchandising everything in this island here. What's going to happen is this island is going to get removed, and we're going to put in our first run of new CO2 cases here. This is what's going to put our first stable load on rack number one. So that's what happens here. So these cases come out. Green is the new transcritical CO2 cases. Everything that was merchandised in those existing lineups is re-merchandised over in those self-contained cases. So this gives the contractor time to install the cases, and this is 15 cases. That's not something you exactly do overnight. And then that's when Dave and the Load Connects team would first start with that remote commissioning process of getting the system up and running and working with the contractor to make sure that the load was stable and that they could then hand that lineup back over to retail. Once that was done, we would just do that exact same process for rack number two. So our whole goal is to get both racks fired up and running and a stable load on those. This allows the rest of the project to continue in a much more like simple HFC-like way where you can just peel off case by case at a time. So same thing, we just reused those self-contained cases that were brought in for that next run. That entire island gets removed, new CO2 island gets put in, that gets commissioned and up and running, and then handed back over to retail. So now we have a stable load on both of the new CO2 racks. So what happens next is we don't need as many of the rental self-contained cases anymore. So a good chunk of those actually go away. We do move some around as we kind of spread out throughout the store. So you can see some of these service departments, they start getting new cases. This island gets installed. But now the rest of the project looks a lot more like you would do with an HFC system. You can do smaller chunks at a time. You don't have to do 15, 20 cases and things like that. Um, we then flipped over to the other side of the store. The store was actually an expansion, so their frozen department was getting bumped out. We did use some temporary cases over here. This was more for simplicity for the reset teams instead of trucking product from those frozen cases way back over here to the side of the store. We just positioned some self-contained cases right by the ones getting swapped out just to make it easier on them. But this part of the project from a CO2 standpoint, once we move over to the frozen side, there's no more heavy load you have to put on the rack. It's already running. That's what we did in the previous phases. So that's how the rest of the project plays out. The Low Connects team and Dave's team, they're constantly involved with this from a commissioning standpoint. It's also, and Dave will talk about this more, the solution the store was using after this was done. He'll talk more about that. This is what the actual temporary setups in some of these stores will look like. We do bring in step down transformers for really large runs in case we do need to power a lot of cases. This way we don't have to run 20 or 30 power drops. We just run one to the transformer. Transformers power the rest of the cases. But this is how this would look in actual store. So with that, Dave, if you want to take over, I don't know if do you want me to, I can run the presentation if you want to talk through it.
Yeah,
Or
yeah,
cool.
yeah, that'd be easier. But
Yep.
yeah, perfect. Cool. So yeah, just to kind of follow on for what Carl said there, in terms of the remote monitoring piece, the aim here is that it works alongside, the design and that entire process Carl's just gone through. The two working in harmony is the perfect situation to make sure that you're kind of delivering this fault-free, optimized solution to the end, but then also the entire life cycle after, it's been installed as well. So yeah, if you want to move to the next slide, Carl. Cool. So yeah, just to go into a little bit more detail around kind of the solution we offer in terms of that remote connectivity. So the aim of our solution and other solutions as well is to kind of centralize now all that data. So obviously, once all those assets are connected, we get remote connectivity, and that would give us access to the telemetry values, to the settings, and all that data would be able to be brought back into the system. Once again, that's very agnostic in the sense of what we can connect to. But that's kind of service provided. It's software that can then sit over this entire thing, give you that kind of centralized view. Yeah, next one. Cool. So this is kind of a process, and this was actually born, and I think it's good to kind of explain why it's born. So for a large food retailer we were working with, they'd started the journey of transitioning to CO2 packs, and they'd done it quite a lot, quite a big scale. They were doing 50 a year sort of scale. And what we found was, even though it was being designed and installed, the remote monitoring piece was almost that missing piece to the puzzle to kind of manage it. So they were running into lots of issues with their packs, a lot of failures, and by tying this kind of process in over the top of the entire end-to-end stage, it just kind of ironed out most of those issues and kind of was delivering these to sites in kind of a way better position, but also a lot less failures and issues down the line. In terms of this process and in terms of how it kind of works, we call it our proving process. So for kind of any kind of new store refit, anything, or even down to an individual cabinet as well, I think that's worth calling out. So not just an entire system, we can even run individual cabinets through this process. And kind of how it starts is, obviously we kind of link in with our customer in terms of their refit schedule, their new store schedule, and we put it then through this process as they come alive. We go through these steps. So take us through that then in terms of kind of pre-work preparation. So kind of the remote monitoring switch on. Obviously, the example that Carl just went through, we're already providing a remote monitoring solution. So in that scenario, if it's a refit, what we get is a notification from the customer say, look, we're planning on putting this store through the refit, and this is the date this starts. And at that point, it kind of starts us to to kick that process off then. So what we do is kind of prepare it. We know the day it's installed, that's all scheduled through the system. And at that point on the cabinets that are being switched off on the days, they will automatically kind of stop the remote monitoring. So it just stops any nuisance. So that kind of stage there captures that, make sure that we're not creating any nuisance from those refits or even in new foot stores sometimes as well. So we're not getting alerts out we don't need. In terms of the on-site monitoring, obviously the bit to call out here is there's lots of different control solutions. Obviously, we agnostic kind of connect to most of them in the market, so we will bring all that data in, depending on what it is. But that is important as part of this puzzle. But I'll go on to kind of the detail around the actual control solution later on a few slides. So in terms of obviously all that work's carried out on site, so we've turned off the remote monitoring. That step-by-step process Carl's gone through and onboarding those assets. At the point of them being onboarded and connected, obviously they hit our system. This is kind of the onboarding stage of those assets in terms of commissioning. And that works for multiple different sections. So that's anything from device aliasing, alarm aliasing, the work order flows, energy initiatives, and obviously a full spec review. So when we talk about commissioning a site, what we found over the years with lots of different CO2 installations is that through that process, when you design, manufacture one of those packs or one of those systems, it's designed to work in a certain way. And that normally gives you a defined specification list to kind of align to. So as part of that process, we make sure it's aligned to that specification and locked down, so then nothing can be tweaked. So that just gives you that consistency, and that's a really key bit throughout this process is that drawn up spec that everyone's aware of, that's consistent, it's aligned to, and any movement away from that specification is carefully reviewed and considered before any action is taken. So obviously we do that process to onboard all those assets. As part of that, we do also pick up kind of asset packs or any of the asset data coming from those systems, but also kind of your F-gas, your gas kind of detail as well around those systems to populate those databases for any regulations that's required. And the end-to-end, so obviously we kind of sit in between with our solution, but that also goes into CAFM. So what you end up with is your control solution, connecting to the asset, sending the data out. It comes into this then centralized solution, which covers off all that kind of alarm aliasing, device aliasing, making sure that's all aligned. And then the final piece is obviously linking that to other solutions, be it a work order system or anything else like that. So obviously it's that kind of final piece to that chain. At that stage, what we do is then launch the site. So obviously the site is launched, it's opened, it's running, and that kind of starts that initial monitoring. And obviously I've touched briefly on the workflows, but that's that kind of full 24/7 monitored site throughout the rule sets. We then kind of move into the proving process. So the proving process is the way that we kind of identify the issues on the site and make sure they're ironed out. We very much treat it as it's not about this is broke. It's not about necessarily pointing fingers. This is about just making sure that whatever's delivered is correct, it's working, and anything that has been identified through that process is resolved collectively as a group between the manufacturers, the customer, the service contractors, any kind of regional managers for that site, etc. So it's just about delivering that site right. And what we do there, and for the first customer, we went very stringent in terms of what we look for is multiple weeks of passes. So what we assume as a fail is almost a single alarm or a single alert from the system is almost a failure. And when we first deployed this in the food retailer I mentioned earlier, we started off saying that maybe 5 alarms would be acceptable, 5 alerts, and actually what we got to was 1 alert equals a failure. And everyone thought, wow, there's a good chance that these stores will sit improving. But we put the process in place. We went through it step by step. And, we did have a few sites that sat there for a long time. But what we actually ended up identifying was issues that if we hadn't picked up would only have caused issues down the line. But at the same time, some of these could be a design, it could be a manufacturing issue, it could be, something wasn't installed correctly, all these different factors, but they're identified. We then learn from them, and then we make sure it's factored into every other site thereon. Moving forward. So yeah, what we do, as I said, was that 4 weeks of passes. So we look for 4 consecutive weeks of 0 alarms from that site, which sounds almost sometimes impossible, but that's exactly where we've got. And we've now put hundreds of sites through this process and delivered it to that line, kind of following these steps. And it's worked really well for us to kind of deliver that consistent and optimized site into an estate. But also we've seen the knock-on effect now, i.e. the reduced noise, the reduced work orders to contractors. That's all just played in, which obviously then is a cost saving on that side as well. And once again, all that is goes for a report. There's a handover process, with meetings in terms of how we manage that as well. So we're constantly there for every single one of those steps, sitting alongside your install, the customer, etc. So, and the kind of reports and dashboards that kind of show it step by step, which work really well. So yeah, so that's kind of a process that we've delivered. We've delivered that now for the last, 14 years. Especially in the CO2 space, it's really supported a lot of our customers going through that kind of transition. Perfect. Cool. So yeah, just wanted to put this slide in really just to kind of talk about, you know, the actual control elements of the control solutions going into the site and then what that links into. So what we've noticed in the marketplace, obviously refrigeration is very much a key one, and most of our customers have started there. But then over time, there's lots of other opportunities with different categories. And what we found is that technology is advanced. There's a lot more options now out there. So where categories might not have been worthwhile connecting, they definitely are now. And the more you bring that into kind of that central location, the more benefits you get. And a really good example of that is really around kind of your refrigeration and HVAC. Those two things, we see it time and time again with our customers where refrigeration is connected and it's having loads of issues. And what it turns out is that the HVAC is, or, your heating is running too warm and it's impacting the fridge. And having those kind of centrally in one place allows you to kind of actually make that as efficient as you can. You can have them working together instead of against each other. And this is really what we're trying to get to here. It's about having all the asset categories that, you want to connect or are worthwhile connecting, give you that benefit back and add that kind of payback into that single location. And then linking it into your other solutions, be it, your CAFM, your work orders, etc. So yeah, just really wanted to put that slide in just to kind of
Yeah, and
touch on.
I'll add to that too. Just this year we had a couple sites we were trying to turn live during the retrofit process, and we were not making it through that proving process. We kept having constant alarm issues, and it turns out only 20% of the site's air handlers were actually working. Very simple thing. This didn't even require remote monitoring. Technically, just required someone going up on the roof and checking these things, but it does have a huge impact. So that is a really easy one that you can knock off with this. That has a large impact on actually getting sites handed over and live. Sorry.
Oh, no problem. Yeah, and so yeah, exactly that. So, like I said, just now where we are, there's other categories now that are worth going after because they give you that benefit, but also, yeah, like I said, that centralized control and being able to manage it all together, just really supports that position. But what I would say is it's always a bit of a journey. You start at refrigeration, you kind of build up over time. We're seeing a lot of customers do that now. So yeah, just in terms of the remote monitoring piece, then just to kind of go into a bit more detail of kind of where we're seeing the market going and just kind of giving that kind of insight on recommendations around controls, etc. Just obviously to start kind of on the left, you've got your multiple different categories, your fridge, your HVAC, your lighting, your IoT as an example, and that kind of all goes down into how you get that data out the solution, or sorry, out the site locally. So what we're seeing now is that we're taking a lot of states that have got very disjointed kind of control strategies. And what I mean by that is you've now got, you might have certain type of controls in one site, another in a different. We've even seen scenarios where you've got two different types of control. And obviously the best place to be is kind of protect the position in terms of the controls you're putting in. So what we've kind of done there to support on that is that open protocol nature. So what we've designed now is a solution that can, pull the data out of those multiple different solutions. So it isn't limiting you then. You don't have multiple different locations to look. What we're seeing is kind of, you could end up with one location where you have to look at this asset, you have another location, and nothing kind of centralizes it. So you end up having to dial into each individual site, but it's almost after the fact. So you're getting an issue, you're then dialing in and looking at it instead of it actually telling you that potentially have an issue, and then you look at it, trying to get ahead of it. So kind of our recommendations around that is that kind of open protocol nature. We always recommend to our customers having, some sort of BMS or solution that is open protocol. And what I mean by that, and there's lots of different terminology around open protocol, but open protocol in the sense that, you can push that data to the destination you want. You can send it to the location you want. So giving you that kind of flexibility. So if you want to push the data to any destination, you can, instead of it being kind of restricted behind going to a cloud solution, i.e., the manufacturer's cloud solution, and then having to API out. We always recommend if you can push the data straight, that's a really good position to be in. At the same time, it's just about kind of getting that into one location. So kind of going on to the next step in terms of the solution.
Oh,
Oh no, sorry, Carl.
okay.
Sorry, the LoConX cloud solution then. So obviously we talked about the proving process and I really briefly touched on the rules, but I think this is a really important piece, especially when we talk about CO2 refrigeration. Um, what we've done there is built a very kind of smart rule engine to allow you to kind of build customizable rules. So what we often see, a lot of control solutions, they'll have alarms. So a lot of the BMS will go, they'll send you out an alarm as an example, but an alarm is almost saying, I've already got an issue, and that's often too late. So how we kind of try to capture that now is actually looking at the telemetry. So the rules can be built off telemetry. It can be built off other factors around weather conditions and all this sort of stuff, and that can all be factored in then. So when you're looking at CO2, like I said, an alarm is a point of it's already failed, and then you're having to go and fix something that's already failed. But by looking at the very small changes in terms of how it operates, that's where you get your biggest benefit, but also being able to compare multiple sites. So like I said, if you're looking at one CO2 pack in isolation, it's difficult, but actually if you've got a visual that gives you all your CO2 packs, and you know that they're all commissioned now to the same set point, you'd be able to actually start identifying the outliers and which ones aren't operating. And that just gives you a different level to be able to kind of identify the issues. And that's really where the kind of the benefit of that centralized view comes in. On side of that as well, it's kind of that automated flow. So when I talk about, the data's being ingested from the site into this solution, running through those automated rules, which are then creating your work orders into a CAFM solution. You can then also make automated phone calls. So once again, if we can see certain load on a pack that's making it struggle, we can have a rule to try to capture that to alert someone that actually, there's an issue here. Could you remove some stock out of some cabinets and isolate one, etc. There's all these different options then to try to mitigate those scenarios. So before it becomes a full failure, you can stop it at a 25% failure. It's just about making that whole process smoother and easier to kind of keep sales going. So yeah, and obviously then that final piece is that CAFM piece. So obviously to make that full automated flow end to end, it's those work orders being pushed in, but at the same time pulling that data back in to then give you those reports and dashboards that gives you those insights in terms of how they're performing, but also alongside your telemetry values, your performance, etc. So just wanted to touch on that. Anything else you wanted to add to that, Carl?
No, no, you're
Cool.
perfect.
Cool. Next slide. Thank you. So yeah, just wanted to end on a few quick case studies really. So this one is an example. This was for a leading grocer. And this was kind of a project purely around that process we've just talked about. So it was about that standardization, getting connected to all their refrigeration, standardizing all the spec, all the set points back to spec, making sure that settings weren't being changed to kind of mitigate, well, not mitigate, but to get around issues and kind of managing that end to end. And from that, we saw, a lot of kind of just from doing it, what we view through that process, there was ended up being quite a large, energy saving across, I think it was 120 sites in total, as an example. So just achieving that saving by just bringing everything back to spec and making sure it's all set up in line with spec generated a saving in its own right before then trying to do further optimization. There was a bit obviously with this customer's RAL, that HVAC bit that I mentioned earlier. So we also brought HVAC in this scenario to make sure the two weren't fighting. So they were working together. And then Kai, if we go on to the next one,
Yep.
this one I'll spend it. So this is a slightly different process, but I think it's a real good one to call out. So this was another customer that kind of prior to this, before we took on this customer, they were very much doing manual monitoring. So at this point, it wasn't connected. There was none of that automation. And what we did was take on this estate, which at the time was around 3,000 sites, around 85,000 assets, refrigeration assets. And obviously for our bureau and our software, we kind of went through and reviewed every single setting, every single alias, and that entire configuration in line with building that spec as well. So when we took it on, they had lots of different manufacturers, lots of different types of kits. So we built that specification out alongside them, and then that's what we aligned it to through the Bureau service and the software. And that equated to around 2 million set points that we had to put back in line with manufacturer set points. So it just gives you an idea of how quickly an estate can drift from what is viewed as its design conditions from a set point perspective. And this is what we're seeing time and time again. And just the saving by aligning all those, obviously, even just from a food safety, but an operational perspective and efficiency, it provides that benefit. So following that, we then obviously that automated process. So from around building the rule sets, automating to the work orders, to then reduce that entire manual monitoring end to end for this estate as well. So this has now been running for years, multiple years, and it's every single refrigeration asset, HVAC, is fully automated from a maintenance perspective. So it's picked up when there's an issue, the work order is raised, the engineer attends, the site's automated, an automated call is made to the site, and that's an end-to-end process. So yeah, it's just once again, just to kind of reiterate that benefit of that process. Yeah, that's me, Carl.
Yeah, no, it was good. The set point standard, I mean, we run into it all the time, where especially during the initial installation and commissioning process, where if there isn't like a tight control on this, where things are done on site to get the system over the hump, get it operational, meet a deadline, that and a set point change is made or a system parameter change is made that shouldn't be made, and it has some long-term effects, that we've seen that happen often.
Yeah,
Um,
and that's led me on to a really good point. Thanks, Carl. And yeah, we very much view that as the foundations. And even though when you talk about saying that we need to normalize 2 million set points, but being in that position is your foundations to then go and do I say more exciting stuff, but the other stuff that's going to give you even more benefit around energy savings, and all that stuff as well comes from those foundations. And those foundations are very much that normalized, that centralized estate, the set points being to manufacturers, spec, etc. That is your starting point, and then from there it's easier to build. When you're trying to build from to kind of manage a state with all these different set points, all different aliases, becomes very, very difficult. We have put a automated aliasing process, so even now any asset we onboard, even if it's a different, multiple different control solutions, all those aliases are normalized as they hit the system. So from a reporting and output perspective, it's consistent. So when the customer's looking at it or anyone's looking at it, it's all the same between multiple different solutions to help that.
I think that might be, yeah, that's the stand of the road.